basic of brushless motor. Brushless motor, you will find in the market a variety of brushless motor, and they have a signification. They have the specifications. You have to, before buying, you have to see the specifications. See, we have a different variety of brushless motor, starting from a big motor like 3536 1050 kV motor. Then I have a 810 kV donkey motor. In fact, this donkey motor comes with combo ESC. I have cut the ESC for my other use. This is something 3511 810 kV motor, and this is Emax 935 kV motor, and it is something GT2218/11. Similarly, there is other motors here. Similarly, is the same kind of motor. It is 2212 13T 1000 kV motor, and you find there is a very small motor. Very small motor. It's about 28,000 kV and 18 to 25 dimensions. Okay, so these are the variety of motor we will find in market. But first of all, we will see what are the parameters which define the brushless motor. Let's come to a donkey motors. We have there is a specifications. You can see ST3511 810 kV. Similarly, you will find the motors like here A2212 13T 1000 kV. Let's find what are the dimension, what are the number represent. Normally, this first two digit represent the dimension of the starter. This is brushless outer running motor. That means this this will be run and this will be starter. So this will be the rotor. In fact, you can see the many motors. It is outer running motors. So the first two digit in this case is A2212, indicates the 22 inch is the scale. If you take a scale, you will find the diameter of the rotor is 22. You can observe, if you observe very clearly, the diameter is about 22 mm, whereas the height it's about 12. It is written 2212. So the height of the rotor is something about 12. Then the next digit you can find in the brushless motor is 13T. 13T indicates the number of turn we have in a coils, and 1000 kV, 1000 kV or 1500 kV, whatever may be, it represent the revolution of the brushless motor per volt with no load condition. Let's go to the black board. Here we have, if you observe the first two digits of any motor, so digit 2212/13T. So this is represent the motor dia of starter, and this represent the height of the starter, and this is represent the number of turn in rotor coils. Now if you have a 1000 kV motor, 1000 kV, this represent the motor can run in 1 volt 1000 rpm. So if you have running with a something like 11.1 volt motor, then the rpm you can get about 1000 into 11.1 rpm with no load tension. When the load will increase, the rpm will be obviously decrease. Now if you have a different kind of motor, you will see different kind of motor, like we have the motor here also you can observe the diameter. It is a 3511 indicates the diameter of the this diameter of the rotor inside the coil. We can have a 35 and height is the 11. Now this number of turn, if more the, it is 810 kV, more the number of turn, the friends, clamps of this two motor, it is connected to a very light aeroplane's light glider. It is very small plane, and it is 28,000 kV motor, but it is 810 kV motor. Here the RPM we are getting per volt is 28,000, but here the RPM is 810, but here the torque, amount of torque is very less compared to this. It can take very high torque, right? So but the thing is that when the third parameter, the number of tons, more number of ton means it is a heavy motor. That means we have a higher torque you can get, and less the number of ton, we may have this here very less number of ton, and hence we will have a higher RPM. So you can say the more ton means it produces more torque and less RPM. Whereas if you have this reverse case, if the number of ton is less, the amount of torque produced will be less, and hence but the RPM will be more. So depending on what kind of aeroplanes, what is the size of the aeroplanes, and we are preferring, we can choose the motors. So you will find the different kinds of motor, like we have starting from 400 kV. This indicate it have a bigger, more number of ton and a very huge motor, and it can give a high torque. And see, sometimes you will find 1000 kV motor. This motor has a almost 1050 kV. It is a bigger motor, whereas this is also 1000 kV. This is also very smaller motor, and so this is also 1000 kV motor. The difference is that here the amount of torque will be more, because the number of ton here is high, that's why it is heavy. But here the number of ton is very less, and it can produce it can go a little bit faster, but the amount of torque it can take is very less. So